Hello everyone, welcome back to the day 6 of TryHackMe's Advent of Cyber 2024. Continuing with the series of the TryHackMe's Advent of Cyber, we are here today with sandboxes. Day 6. If I can't find a nice malware to use, I am not going. So let's continue with the story of today. Maya Malware was scheming, quite full of delight, to ruin sock mass and frightening sock teams. But Glitch and Mix Kitty had spoiled his plan by uncovering secrets that exposed the man. Maya Malware slammed his hand on the table, his eyes narrowing as the report flashed on his screen. Glitch and Mix Kitty had uncovered his trail. He took a deep breath, claiming himself. No matter, he muttered, a sinister grin forming. They may have found me, but haven't spotted me. His confidence steamed from the malware he had crafted, so devised and advanced that it would easily evade detection. But before unleashing it to wreak havoc on SOC teams and ruin SOC mass, there was one final step. He needed to test it in a sandbox. So, what is sandbox? Let's learn that first. He slipped his malware into a sandbox to see what tricks it could play and what flaws there might be. For sandboxes, you see, are used by the wise. Defenders inspect, but attackers revise. Detecting sandbox. A sandbox is an isolated environment where malicious code is executed without affecting anything outside the system. Often, multiple tools are installed to monitor, record, and analyze the code's behavior. Mayor malware knows that before his malware executes, it needs to check if it is running on a sandbox environment. If it is, then it should not continue with its malicious activity. To do so, he has settled on one technique, which checks if the directory C program files is present, querying the registry path, software Microsoft Windows current version. The value can be confirmed by visiting the registry path within the registry editor, as shown below. Let's replicate these actions by coming to the Windows button here and then searching for registry editor. And then once that's open, let's go to the section of software. Inside software to Microsoft, and then scrolling down to the point where we get our Windows, and then we select current version. Now here you can see the C program files, which confirms that yes, this particular virtual machine is not present inside a sandbox environment. So this file is usually absent if you're running in a virtual environment or if you're running in a sandbox environment, because all these are critical file locations or file paths that is there in your system, and you of course don't want the malwares to be knowing those locations by default until unless it's hard coded in the program. So this is a location where it is going to be absent if it is running in a sandbox environment. So what does malware do now? He comes up with this idea and writes a C program which is going to look for the registry entry of the system. Now you can see the code down here which says void registry check. It's a function basically, constant char registry path, which is going to be defining the location where the registry entry is present, the same location which we were browsing from our another tab of Windows system. And then it's going to set a value name, program files dir, which you can see it from this location. Program files dir is pointed to the C program files. Preparing the string for the command, which is going to be the registry query %s, which is going to be printing out the registry path and going to be checking for the folder name or the file value name called as program files dir in this location. So then it's going to run the command, and if the result is 0, which is true, it says registry query executed successfully, and if there are any errors caused, it's going to say failed to execute the query. So don't worry, you don't need to understand every detail of the code. All you need to know is that the function is designed to check the system registry for specified directory path, program files dir. This path's presence or absence helps the malware determine whether it's running in a typical or a virtualized environment like a sandbox. Can YARA do it? Malware Malware knows that Mixkitty is a big fan of YARA rules. YARA is a tool used to identify and classify malware based on the patterns in its code. By writing custom rules, analysts can define specific characteristics to look for, such as a particular string, file headers, or behaviors. And YARA will scan files or process to find matches, making it invaluable for detection malicious code. Malware Malware does not think such a simple tool can detect his malware, but just to be sure, he has to test it out himself. To do this, he wrote a small script that executes a YARA detection rule every time a new event is added to the system monitoring log. This particular YARA rule detects any command that tries to access the registry. Let's look at the rule. Rule sandbox detected. Meta description detects the sandbox by querying the registry key for program path, author, date, version, string, command, software, Microsoft, Windows, current version, and program files, DAR, no case, and condition. So it's basically entering the command to look for any of the strings that matches in the program for the registry path where the program DAR is stored. Let's understand the contents. In the string section, we have defined variables that include the value to look out for the CMD. In the condition section, we define when the rule will match the scanned file. In this case, if any of the specified strings are present. For his testing, Malware Malware has set up one function script that runs the YARA rule and logs a true positive in the C tools YARA match.txt. Open up a PowerShell window, navigate to C tools directory, and use the following command to start the EDR. So let's say jinglebells.ps1 in our PowerShell command. Let's replicate these tasks. Let's open up PowerShell here and then make it to full screen. Browse the C tools folder using the command cd c and tools. Here we can list out all the files and folders which is present inside the directory by using the command ls. And here we can see our PowerShell script called jinglebells.ps1. So let's run the tool by saying jinglebells.ps1 and press enter. So it says no events found in the system log. Monitoring Sysmon log events, press Ctrl C to exit. No new events found. That's good. So which means our tool is actively monitoring for any changes to be present or to be made in the registry file. And if it does find for any events which matches or which does some changes to the registry, it's going to give us a notification about it. So let's continue reading this. Now run the malware by navigating to C tools malware and double click on merrychristmas.exe. So let's go and replicate that action. So open the files here and then under this PC, C, under C go to tools, here go to malware and then run the christmas.exe file. So which actually showed some pop-up or some terminal and it just got shut down. But if you come back to the PowerShell here, and here we can see that we have got our notification saying that malicious command detected, which is the notification generated from our PowerShell script. If you come back to the PowerShell script which we were running, you can see that it says YARA result sandbox detected, and it says the location to the file which it was running, and the event log file where it was run from, and then the event time, what time the file was executed, the event ID, and the event record ID, which is a set of strings or numbers which is going to be having a incremental value of all the records that is done in the system. Command line registry, what it was containing, which is to the program files dir. And you can see all the other information related to it from here. Coming back to the page, we can scroll down to say adding more evasion techniques. It seems that YARA can detect the evasion that Malware Malware had added. No worries, because we can make our malware even stealthier by introducing obfuscation. So obfuscation is nothing but a process of hiding your tool by encoding the program using any of the open source programming algorithm, such as base64, binary, etc., which is going to make your program look more confusing and more of a mess to a YARA rule or any of the file monitoring system, which looks for a particular set of strings or characters to be present in the program files while it was executing. So this goes through the process of encoding the program, and then while during the execution, it's going to decode the program and then it's going to be running, which makes it difficult for the YARA rules or any of the other software application which works on the basic principles of finding out from the strings. So here the program is being modified where we can see a base64 character being implemented here instead of the basic direct command. So let's copy this base64 and look at what contents are present in it using one of the popular decoding tool called as CyberChef. So let me open up my CyberChef here and then paste in the encoded text, which presumably looks like a base64 character. Let me search for from base64 and then put it, drag and drop it to my recipe, which gives us a bit of weird characters, for which all that we have to do is to remove some null characters. So let's search for remove null bytes, which is just going to be removing all these spaces. Drag and drop it to your recipe box, and here we can see the command. The one which is encoded is being decoded using base64 to see the command which says get ID property path to our registry entry and the name program file dir. So which is going to be bypassing our initial YARA tool or the YARA rule which we had written, saying or looking for the string for the registry entry. Now the same goes on with encoding and decoding of the commands by using the function encode command and while running it through the system command here. Be aware of flaws. While obfuscating is helpful, we always need to know that there are tools available that extract the obfuscated strings from malware binaries. One such tool is Floss, a powerful tool developed by the Mandate that functions similar to Linux strings tool but is optimized for malware analysis, making it deal for revealing any concealed details. To try out Floss, open up a PowerShell window and enter the following command. So let's replicate this particular command by coming back to our PowerShell here. Let's open up another PowerShell by right clicking on the window and then clicking on PowerShell. Let's navigate to the location which is present in C tools and listing out all the contents in it. Here we see a directory called as floss. Let's browse into that directory using the same command cd floss and listing out the contents of the files. Inside we see floss.exe and then run the command floss.exe. Let's specify the location of our malware tool, so which is C tools malware merry christmas.exe, and also specify an out file which is going to be saving the contents of this file to the mentioned directory, which goes to C and tools. And now let me mention it as merrych.txt and press enter. It's going to take its own time to analyze and prepare the output for us. Till then, let's go to the description of it. Floss.exe, C tools malware merry christmas.exe. This command scans for strings in the binary merry christmas.exe. If any hard-coded variables were defined in the malware, Floss should find them. The pipe symbol redirects the output of the command and in front of it to the input of the command behind it. So which is going to basically redirect the file or the output of the command which we have given to the file malstrings.txt. In our case, it's merrych.txt inside the tools directory. Once the command is done, open malstrings and press Ctrl F to search for the string mayor malware. enter the flag as to answer the question 2. The format of the string is THM. So let's wait for the program to be executed. And you can see that the function is already run and we might have an output of it. So let's go back to the directory of tools and then let's look at the contents here. We see that we have a file which says marych.txt. So let's open that particular file using Notepad. Let's run the command start marych.txt and press enter, which is going to open this in the Notepad. Now using Control F, let's search for the THM. And we see our flag to be here. Coming back to the description. Using YARA rules on Sysmon Logs. These YARA rules are becoming a pain to Mayer's backside. If he wants his malware to be undetectable, he needs to research how YARA rules can be used to stop him. For example, his research tells him that a YARA rule can also be used to check Sysmon logs for any artifacts left by malware. He needs to test this as well. Sysmon, a tool from Microsoft's Sys internal suite, continuously monitors and logs system activity across reboots. This Windows service provides detailed events data on the process creation, network connection, and file changes. Valuable insights when tracing malware behavior. A YARA rule will look for events with the event ID process created for this to work. There are many entries in Sysmon log. To make it easier to find the event we are looking for, we will apply a custom filter using event record ID that will see in the event log YARA matches.txt located in the seed tools. Open up a PowerShell window and enter the following command to check the contents of the EDR log file. Get content C tools YARA matches.txt. Okay, so let's go to the system. Opening up our PowerShell and specifying get content YARA matches.txt. Now here we see a lot of information related to time, event ID, event record ID, and the command line using the and also the YARA result of it. Note down the event record ID value. We will use this value to create a custom filter in the Windows Event Viewer. Next, open up Windows Event Viewer by clicking on its logo in the taskbar. On the left side, navigate to the Application and Service Log, Microsoft, Windows, Sysmon Logs, and Operational. So let's go there. Let's replicate those steps. Let's click on the event log or the event viewer. And then let's browse to the application and service log. Here, let's go under the Microsoft and then choose the Windows. And scrolling down, we see Sysmon logs or the system logs to be present. Here, we see operational. Here, right click on the operational and go to the options which says filter current log. Here, choose the XML path. And let's write a custom query given by TryHackMe to narrow this feature down to the one which we only want to see. So the query is here. Let's copy this query, come back to our system and select the option which says edit query manually, confirm with yes, and then paste in the query here. Now I'm not going to be doing that due to it. I need to manually type in those commands. So hence, I'll just continue reading, going through the description of it. Replace the event record ID with the value with the one you recorded before. Apply the filter by clicking on OK. Now you will get the event related to the malware. Click on the event, then on the details tab, you should get the following output. So this is going to be the output of the one after you enter those parameters and queries. So here you will be able to see a lot of information which is given down here, which says, let's look at the event data that is valuable to us. The parent image, he shows us which parent process spawned the cmd.exe process to execute the registry check. We can see it was a malware located at ce tools malware merry christmas.exe, which is the command here or the parent image location given there. The parent process ID or the process ID keys valuable are valuable for follow-up research. We could also use them to check other logs for related events. So the process parent process ID is located here. The user key can help us determine which privileges were used to run the command.txt command. The malware could have created a hidden account that used to run the commands. So you can see the parent user or the user which or who ran the malware there. The command line shows the keys. Key shows which command was the command line key shows which command was run in detail, helping us identify the malware's action. The UTC time key is essential for creating a time frame for the malware's operation. This time frame can help us focus on your threat hunting effort. Never gonna give up. His malware, it seemed, wasn't quite ready for town. There was watchers and scanners and rules by the town. If I'm not careful, they'll catch all my fun. Mayor Malware leaned back, tapping his fingers thoroughly on the table. All of his research had revealed an unsettling truth. His malware was cunning as it wasn't ready yet for the wild. There were too many tools that too many vigilant eyes. Analysts armed with YARA Rules, Sysmon, and host of detection techniques that could expose his creation before it had even had a chance to spread. Wow, the angry malware. He clenched his fist and determined glint in his eyes. Just a little more fine tuning, he murmured. He would study, adapt, and evolve his malware until it was truly undetectable. When the time was right, he would then unleash it upon the unsuspecting SOC teams, striking when they least expected it. But for now, he would wait, watching, planning, and he was perfecting his craft in the shadows. So that was the challenge of today. I will submit the flag later after this video. So hope you enjoyed day 6 of Advent of Cyber. It was a fun for me. It was all about analyzing the logs and creating and running some malwares which was there. It was about the sandbox environment, understanding about sandbox, and even looking at the events and the processes, YARA rules, and all of those things. Hope you enjoyed it. If you did, please hit on that like button, and if you're new to this channel, hit on that subscribe button and hack YouTube's algorithm by liking, sharing, and subscribing. That's the only ethical way to hack YouTube. I mean, the hack YouTube's algorithm. Until unless you want to get the silver, nice bracelets into your hand by YouTube. Other than that, that is it for this video. Hope you tune in back tomorrow for day 7 of Advent of Cyber. Till then, that's it. Signing off. Bye bye. With